Hello students, today we are going to talk about a device which is known as transistor. What is transistor? Actually, when we sandwich, means a p-type semiconductor is sandwiched by two n-type semiconductors, or a n-type semiconductor is sandwiched by two p-type semiconductors. That means they are fused into it, then that is known as a transistor. Why do we call it transistor? In fact, it transfers the resistance, means it enables the charge to move easily through the barriers developed at the p-n junction of a p-n junction diode. Here you see, if you look at the transistor, you can imagine that it is a combination of two p-n junction diodes. N-type, here we are talking about PNP transistor. If N-type semiconductor is sandwiched by two P-type semiconductors, then the transistor is known as PNP transistor. And if instead, if P-type is sandwiched by two N-type semiconductors, that is known as NPN transistor. So here we will talk about PNP transistor. What we have done, N-type semiconductor is sandwiched by two P-type semiconductors, and that is done by fusing the P-type into N-type from one phase and fusing the P-type into N-type from the another phase. Then the structure created is known as a transistor. Now here we have three parts. One is called emitter. One phase of the transistor is known as emitter. The middle part is known as base, and the remaining other phase of the transistor is known as collector. Now to have a particular purpose served, what we do is, emitter is doped very highly and its area is kept moderate. Base is doped very poorly and its area is also kept very small. And the collector region is doped moderately and its area is the largest among all the three. Now we will understand how this approach helps to make the conductivity within our control and easy. The symbol for a PNP transistor is like this, means if we have a forward bias for emitter and base, then whatever will be is the direction of conventional current, the arrow shows that direction. So if you see P and N, that is emitter and base, are forward bias, means P side should be connected to positive and N side should be connected to negative terminal of a bias battery, and therefore the current will start flowing from P type into N type. And so we show the arrow. This arrow is showing the direction of conventional current when the input circuit, that is emitter and base circuit, is forward bias. So this is how you can remember when the arrow should be in this way. This is the case of PNP transistor. And if we talk about symbol for NPN transistor, then in that case the symbol will be slightly different. Here you have emitter as shown here, with the arrow showing the flow of conventional current. This is for NPN transistor. In this case, what you see, for NPN transistor we have this here, emitter is of N type and base is of P type. So that means we must have, to forward bias it, we must have the emitter connected to negative terminal and base connected to the positive terminal. So only then it will be forward bias, and if that is done, the current will flow from the conventional current, of course, will flow from base to emitter, and that is shown by the arrow, the flow of direction of conventional current when the input is forward bias. So this is how you can remember the symbol. Now we talk about the how the transistor acts. The word transistor is derived from the combination of two words, transfer and resistor. So it becomes transistor. Now we have the transistor. Transistor can be used in three configurations. Means we might have common base configuration. So here you can see you can create a circuit over here in which the emitter base is forward bias and the collector base is reverse bias. So for making it reverse bias, what happens? This the collector is negative, so we have to keep it at positive terminal so that it becomes reversely biased, and then we connect the base to the negative terminal. So the output circuit is reverse bias and input circuit is forward bias, keeping base in common, and therefore it is called common base configuration of transistor. We can also have common emitter configuration and common collector configuration of the transistor. So we will try to understand how the current is regulated in case of common base PNP transistor. We are talking about one particular type of transistor, and then you can generalize it for another type of transistor as well. Here we have a PNP transistor and we take it in the form of common base configuration. That means the input is that is emitter and base is forward bias and collector and base region is reverse biased. As you can see over here, this strap is the metallic cap which ensures the proper connection, connectivity with the emitter, with the base as well as with the collector. Now if we talk about PNP transistor and it is in common base configuration, how it works, let us see. You have forward bias, the input circuit, that is emitter and base is forward bias, and therefore under the influence of this forward bias voltage, the holes of the emitter are pushed into the base region where there are only few number of majority charge carrier, that is electrons, because we have already ensured to get this situation created by doping the base very poorly. If we dope the semiconductor very poorly, that means the majority charge carrier will be very minimum, and we have also kept the area of the base, the surface area of the base small. So what happens when these holes coming from emitter, the emitter is highly doped, so there are abundance of majority charge carrier holes in this p-type semiconductor, and when these holes enters into the base region, they find a very few number of electrons which are the majority charge carrier of base, and with them they combine. Only a few of the holes combine with these electrons because there are only few number of electrons available to combine with the incoming holes from the emitter zone. So now the remaining unpaired, uncombined holes finds less space in base and also a favorable field of the collector pulls it across the barrier potential of the base and collector region. Here is the barrier potential of base and collector region, and that barrier potential is overcome by these holes under the influence of high potential of the collector, and due to reverse bias, and therefore once these holes are able to reach the collector plate, it provides a large current flowing across it, and that means the collector current is very large, because all the uncombined holes coming from emitter and passing through the base reaches the collector and finds a favorable field and to get collected by the negative terminal of the reverse bias voltage, and as a consequence the high current is produced at the collector end. And from this situation you can very well understand, under the concept that the charge are conserved, you can very well say that the emitter current, that is current generated at emitter, is equal to the current generated at base plus current generated at collector. So here if you mark the current, emitter current, it is along this direction, and some of them are reaching over here, the base and the holes are, some of them are combining over here, and the rest are reaching over here. So that means here we have the collector current and base current, here we have the base current. So that means this is how the circuit is completed, means the total emitter current is equal to base current plus collector current, and the collector current is nearly 95% of emitter current. So this is how we see that though there was a resistance, the charge carrier, majority charge carrier, are able to flow across the transistor, and hence the name transfer of resistor, and this is called transistor action. Now in case of other configurations, we can have common emitter and we can have common collector configurations. The similar phenomena takes place. So that is how a transistor works. That's all for today. Thank you and have a nice day.